Okay, so I think with this one, obviously, we got to prove that this side is equal to this side. I think it's going to be better to start with this side. Start with the left-hand side. Okay, so say left-hand side equal to, and now it looks to me like the best thing to do is just to expand it. Okay, use the compound angle identities. It's going to get long, but that happens sometimes with these ones. They can get long sometimes. Okay, so we're going to say sine A plus B, first of all, this one, is sine A cos B plus cos A sine B. And then we're going to say sine A minus B is sine A cos B minus cos A sine B. So we're going to write that whole thing down. Okay, so we're going to say sine A cos B, okay, and then minus plus cos A sine B. So that's this one, okay? And then we're going to do the same with this one. So we're going to say sine A cos B minus cos A sine B. Okay, so we write it, we just expand it. And now you can see it's the difference of squares. This bracket looks exactly like this bracket, but this one is a plus and this one is a minus. So it's a difference of squares. So we can change it to square this one, sine square A cos square B, and then minus that one, cos, or this one, just square any one of those two, cos square A sine square B. Okay, so we just square them. And now, the thing is, if you look at this, and you look at where you're supposed to get, if you look at this one, it's only cos square, no sine square. So what you can do is you can say, change the sine square. Remember, sine square plus cos square is equal to 1. Sine square x plus cos square x is equal to 1. Okay, you remember that from last year? Okay, the identity. So when you take the cos square over, you get sine squared x is equal to 1 minus cos squared x. So that's stuff we did last year, right? So you can say, well, let's put sine square A. Let's change the sine square A to 1 minus cos square A. Okay? So we're going to do that now. We're going to say, let's change this one, sine square A. Let's make it 1 minus cos squared A. And then we leave the cos square B. Okay? Just change the 1 minus sine squared to cos squared, and then here we do the same, sine squared B. So we're going to say leave the cos squared A and make the sine squared B 1 minus cos squared B. Okay, so now the reason why we did it is now we only have cos squared everywhere. Okay, because that's what the answer looks like, just cos squared. So now we can multiply it in. 1 times cos squared gives you cos squared B. And then negative cos squared A times cos squared B, you just write it down. Negative cos squared A, cos squared B. Then here you multiply it in. So you get negative cos squared A. And then minus and the minus gives you plus cos squared A, cos squared B. And now they cancel out. The minus cos squared A, cos squared B plus cos squared A cos squared B cancel out, and you just left with cos squared B minus cos squared A. Cos squared B minus cos squared A, which is equal to the right hand side. Okay, so the important thing is that sometimes the hand is just quicker than the brain. Sometimes you can't see where you're going to get, but you just write out what you know. You know how the compound angles work. You just write it out. And then you see what happens. Okay, well, now we got difference of squares. So write it down. Then you just check, okay, what can I do? I got to get this. I got to try something. So I say, okay, well, let's just change this to cos 1 minus cos squared so that we can get rid of the sine squares and see what happens. And then when you just write down, sometimes it just starts falling into place. Okay.